Alright, welcome back to another part of the video. So we're getting close to the end. Okay, we have only two more cases to be explained here. So let's move on to the case 2. Case 2. It is said that the square root of b square minus 4ac, not square root actually. What did I do? We just look inside of this. B square over b at 4ac is more than 0. Now I will do some multiplication in substitution here. So b square, you know that is equal to y square over 4m square minus with the omega naught square more than 0. Or when we do some of the more in depth, it is gamma over equal to more than 2m omega. So what happened when the gamma is, which is the damping constant, is more than this one? So this is what we call as I think it's for overdamp. Yeah, overdamp. Okay, overdamp. I think I cannot explain more about this because not more. I think how the graph shows, because it is not the lecture note is not open yet, but I already have the lecture note of it from the senior. Thanks to the senior who give the lecture note earlier. So later I will explain it in the next lecture. Okay, lecture note. So here is the overcam here. So from this one we do some of the what we call we define a new constant. Okay, there is a new constant which is the q. Okay, q. Okay, so q. Okay, q here is equal to here. So q is equal to gamma square over 4m square minus gamma square minus omega naught square more than 0 here. Okay, from here, since that we have the inequality, since we have the inequality, now let's look on the alpha. Let's look on here. So x equal to negative b square plus minus square of 4ac over 2a. Okay, let's look here. Alpha is equal to minus gamma. No, not b square. Negative b. Okay, negative gamma over m plus minus square of gamma square over 4m square minus omega naught square. Okay, right now it is said that this one is more than 0, and when this is more than 0 here, that means we have a quantity inside here. So that means we have a positive quantity and negative quantity. So that means we have two possibilities, which is positive q and negative q, which is positive quantity, negative quantity, because we have plus minus here. Okay. Now from here, when we do some of the quadratic solution, there should be two answers, right? Because there is two quantities here, plus and minus. So we have alpha 1 is like x1, x2. Okay, alpha 1 is equal to negative gamma over m. Okay, plus with the square root of q. Okay, easy. Okay, it's pretty easy. Actually, hold on. Yeah, I made a mistake here. Sorry. Okay, this right here is the q square. Okay, q square. So here is the q square. So finally we get that it is equal to negative gamma over m plus q. Sorry about that. That's why I feel like I'm so weird. Okay, this is the first quantity, first alpha. Okay, now we have alpha 2, which is negative gamma over m minus with the square of q square, and here is negative gamma over m minus q, which is alpha 2. Okay. Okay, now it is time for us to do some of the what we call as the substitution. Okay, first I will explain more here. Notice that okay, this one has like let's say that this is actually not a complex number. This is like a original form, and this is its conjugate. So since we have the original form and conjugate, that means we can do what we call as the solution. The solution to form one. The solution. It is used to form a one solution. Okay. So we know that we want to form. The purpose of we do this to find a solution. To find the solution of displacement. What is the displacement for this case? How do we calculate displacement for this case? Okay, so we have xt, we know that is equal to exponential power of alpha t plus, multiply with capital X t, right? Okay, since we have 2 alpha, so that means we have to find, that is like S1, okay, that is S1 and X2, which is equal to exponential power of alpha 1t, okay, multiply with capital Xt, and we have the exponential power of alpha 2t times with the xt. Okay, pretty simple. Simple. Okay, now I want to show you that okay, this right here, how do I say this? I'm dizzy right now. I'm confused. Okay. Right here. Okay, since we know that, okay, we have the x1. Okay, just a minute. Okay, x1 is equal to exponential power of alpha 1t times with the xt. Okay, so capital Xt is actually b. Okay, we want to this is like a constant here. This is a constant. So this one become x1 equal to exponential power of alpha 1t times with the b, and which is equal to b1 exponential power of alpha 1t, and finally this is equal to b1 exponential power of alpha 1, which is right here, negative y over m plus q, negative gamma over m plus q, okay, and then times with the t. Okay, this is x1. Now let's look at the x2. Okay, x2 is equal to exponential power of alpha t to t times with the capital Xt, and xt as the new constant, which is b2. So x2, I'll just do just the straightforward substitution. So b2 exponential power of negative gamma over m negative q. Okay, that's it. And then times with the t. So let's look back here. So let's just write back. So this one is equal to b1 exponential power of negative gamma over m plus q times b, and here is beta 2 exponential power of negative gamma over m minus with q times with the t. Okay, yeah. Okay, complete. This is the most torturous chapter I've ever done. Okay. Now, if we want as you can see, we can actually do what we call it as the addition. Addition, why we do addition? Because we want to remove the quantity of Q actually. No, I'm so sorry. We want to do what is called as the, how do I say this? You know what? Forget it. Okay, I'll just show you so that you can analyze by yourself. Okay. Xe is equal to x1t plus x2t. Okay. Now we add up this part of this. So we find that it is equal to b1. So we beta 1 e power of negative gamma over m plus q times with the t plus with the beta 2 exponential power of negative gamma over m negative q times with the t. Digit is so torture. Oh my god. Okay. Okay. Right now, okay, I want to make a form that is resemble like this one. Xe is equal to exponential power of alpha t times with the xe, right? So we know that xe is equal to b, and exponential alpha t we have to factorize. Okay, this one is the same as exponential power of negative gamma over m, and then plus q t here, right? Or maybe negative gamma over m negative q times with t. Okay, from here we just only factorize this one here with this. This one we put aside. Okay. So finally we get that xe is equal to, now I factorize here, exponential power of negative gamma over m. Okay. Actually not gamma over m, actually 2m. Ah dear. Another mistake. Come on son, are you serious right now? 2m here, 2m. Then show me 2m here. This is 2m. This is 2m. I'm so sorry. Okay. Negative gamma over 2m. And then plus gamma 2m times with the t. Times with the t. It is here. This chapter, I honestly, I'll say this chapter is really tough. So you have to do some analyzation by yourself. So exponential power of negative gamma over 2mt. Okay, gamma 2m times with the t, right? From here. Okay, and then open bracket. This is represented as exponential power of alpha. Actually, this is not alpha. It's like we call it as the modification. Okay, and then times with the beta 1. Okay, and then exponential power of qt, and then plus gamma beta 2 exponential power of negative qt. This is where it is the x, capital X here. Okay, now I will show you the proof that we will get the exact as this one. I will do what we call it as the kembangkan. Okay, kembangkan. So I'll do again. So xe. It's like I want to show proof here. Show proof. Okay, so xe is equal to exponential power of negative gamma over 2m, then times with t, and then multiply with beta 1 exponential power of qt plus with the beta 2 exponential power of negative qt. Calculations. Oh dear. Okay. Now, here, since I do some multiplication, each one of them, what happens is here is when we have a base, the same base that can be to do some multiplication, we say that e power of q times e power of q. Okay, this is example. So what happens when we get that it is actually equal to e power of q plus q, right? We will do some addition instead of multiplication directly. Yeah. So this is as this z plus this one. So it is equal to exponential power of gamma over 2m. Okay, and then times with the t, right? And then plus qt. Okay, and then times with the b1, beta 1. Okay, and then plus again as the same one, which is exponential power of negative gamma over 2m times with t, and then minus, because multiply with the minus here. Okay, you know what? Let's just plus. Okay, plus and then minus instead. Okay, qt. And then times with the beta 2. And finally we get that I will put beta 1 in the front. So beta 1 times with the exponential power of negative gamma 2y over gamma over 2m plus with the q, and here actually times with the t. We do some of the what we call as the factorization. Okay, and then plus with the beta 2 times with the exponential power of negative gamma over 2m, and then minus q times with the t. Now this is the proof that this one right here is equal to this one right here. Is it same right here? Look at it. It is the same, right? Pretty simple. Okay. Now we're done for that. So this one is the which one is the final form? Okay, here. Okay, this one here is used to find displacement for damping oscillation when it is overdamped. Okay. Okay. Now let's move on to the last case. Finally. Okay, finally. Last case here. This time to now I understand why the lecturer doesn't teach us, but they want us to discover instead of teaching. They just read the slides. Now I see why. Now look at it. Okay, this is the toughest one. It is the last case. Case 3. So case 3 is a little bit different. So it is actually b square minus 4ac, which is less than 0. Case 2 more than 0, and case 1 is equal to 0. Okay. Okay. Now let's go back here. So b square minus 4ac is equal to gamma square over 4m square minus omega naught square, which is less than 0. Okay, pretty simple. Exactly. Or we can say that gamma is equal to 2m omega naught less than. Please remember that. So when the gamma or damping constant is less than this, I don't know how to call this. Let's just say that's this. Okay. When the gamma or the damping constant is less than this quantity, we will find that the oscillation is underdamped. Okay, underdamped. Please remember that. Okay. Okay, right now we want to do we want to find a new constant. Define a new constant. So there is a new constant. They say that this one right here is equal to omega squared. Okay, so omega squared is equal to gamma squared over 4m squared minus this omega naught squared less than 0. Pretty simple. Alright. Not pretty simple actually. I almost died learning this. Okay. Okay. Now let's look back here. Okay. This is the toughest. This is actually tougher to explain. Okay. How do I explain this? Okay, let's look back here. We know that alpha is equal to negative gamma over 2m plus minus square root of b square. Sorry. Okay, what did I say? What the fuck? Gamma square over 4m square minus omega naught square. Okay, finally. Oh dear, I think I do so. Okay. Okay, they want to do what we call as the upside down. Okay, this one right here will become negative. This right here become omega square. They want to do what we call as the interchangeable. Okay, interchangeable. Okay, so that this will not become as this one. It's like the opposite of this. Okay, this is minus. So that means this is not equal to omega 1 or omega 2. Okay? Let's just forget that. Okay. Now here we have omega equal to we have omega equal to negative gamma square over 4m square. Yeah, omega naught square, which is less than 0, right? So we know that this quantity is less than 0. Less than 0 means that when we do some calculation, okay, inside this equation, we will get a math error. So that means this right here will become I omega. So that it will satisfy the equation, which is negative square root of expression negative gamma square over 4m square plus omega naught square. Okay? This is because we have omega square, and then we do square root both sides, and this is what we get. Okay. Okay, so good. Okay, now let's move on. What if we do what we call as the upside down, which is means that I say that I want to make this value positive, which means that I have to do what we call as this one. Omega is equal to square of. Right now this is negative, right? Right now I want to make this value much bigger than this one, so that when we do some calculation, this value, this quantity is positive. So gamma square over 4m square minus omega naught square. Finally, so here we know this is actually more than 0. We know that, right? So that means this value can be calculated. So it's like we want to do the opposite of the imaginary number. So this right here, okay, how do I see this? Okay, let's just say that how do I see this? This is so tough to explain. Oh fuck. Since that this can be calculated, that means it is opposite of the definition of imaginary number. So that means when we put outside here, this imaginary number become negative I omega, which is equal to square root of gamma square over 4m square minus omega naught square. Okay. This is what it is. Okay, let's go back into here. Okay, since that we have two quantity, which is plus minus really, right? So that means we have omega not, oh sorry, we have the what we call it as 2 alpha, which is we have alpha 1 and alpha 2. We have, which means that we have two solutions for one exactly solution here, alpha. So alpha is equal to negative gamma over 2m, okay, plus minus, sorry, plus with square of gamma square over 4m square minus omega naught square. This is alpha 1, and alpha 2 is equal to negative gamma over 2m minus square root of gamma square over 4m square minus with omega naught square. Okay, right now as I said that this here is equal to this here, right here, which is imaginary number times this omega. This is this one too. I omega. Sorry, negative. I apologize. Okay, and then finally alpha 1 is equal to negative gamma over 2n, and then plus with plus minus also, plus minus I omega, and then alpha 2 is equal to negative gamma over 2m minus with minus I omega. Right? Okay, and alpha 1 is equal to negative gamma over 2m minus I omega, and alpha 2 is equal to negative gamma over 2m plus I omega. Okay. As you can see, this is I2, sorry, oh my god, okay, alpha 1, so stupid, alpha 1, okay. So as you can see, this is the real component, right? This is what we call the original, and here is its conjugate. This is the conjugate. Why? Because of this minus and plus. Still same form at the first one, and we have the different form at the second one. Okay, so here is represented as alpha 1 equal to a plus, sorry, not plus, this is negative, right? So negative bi, and alpha 2 is equal to a plus bi, and alpha 1 is equal to negative gamma over 2m minus I omega, and alpha 2 is equal to negative gamma over 2m plus with I omega. So here we know that a is equal to negative gamma over 2m, and b is omega, right? It depends actually. Okay, now let's work on here first. So xt is equal to exponential power of alpha t times we get xt. Okay, and then xt is equal to exponential power of alpha, which is s1t. S1t is equal to exponential power of alpha 1t times with the xt, and then x1t equal to exponential power of negative gamma over 2m minus I omega t times with the xt. So xt is a constant, so x1t is equal to exponential power of negative gamma over 2m minus I omega times with t times with the e1. Now what is x2? So x2 is equal to exponential power of alpha 2t times with the xt, and then x2t is equal to exponential power of negative gamma over 2m minus plus I omega, and then times with the xt. Yeah, and then finally x2t is equal to exponential power of negative gamma over 2m plus I omega, and then times with the t2. Finally. Okay. Now let's add up all of them. So xt is equal to x1t plus x2t, and xt is equal to v1 exponential power of negative gamma over 2m plus minus I omega t, okay, plus with the v2 exponential power of negative gamma over 2m plus I omega times. This is like okay, now I want to factorize. As this one is the same, right? This one is the same. So you get that xt is equal to exponential power of negative gamma over 2m times with the t, right? Okay, times with t, and open bracket v1 exponential power of negative I omega t. Okay, and then plus with beta 2 exponential power of I omega. Okay. Now what? Okay, this is what represent as the exponential power of alpha t times with the x t. Okay, this one can be read through like this one. Like this one, I think. Okay, this one here. So this represent as the beta exponential I omega t plus beta star exponential power of negative I omega t. This is the symbol, okay, the symbol 2. Okay, and then it is equal to this one, a over 2 sine pi naught minus and yada yada yada. So a over 2 sine pi naught, okay, plus I a over 2 cos pi naught, okay, and then exponential power of I omega t plus with the a over 2 sine pi naught minus I of a over 2 cos pi naught times with the is the what we call it as the its conjugate, so exponential power of I omega t. Okay. This one is fine. So this one is fine. Okay, let's see. Let's go back here. I think we have to reverse that. Yeah, I think we have to reverse. Yep, we have to do reverse. Oh, right. Okay. We have to do reverse. Now I see. Okay, this one can be factorized. Okay, be aware that this is actually the exact same but different position. Okay, so this one can be factorized here. So we found that it is equal to a A over 2 sine pi naught. Okay. Hold on, I need to look back. I have to copy that. This one. A over 2. What's the hell? Okay, this one. A over 2 sine pi naught. Okay, each one of them gets a different value here. So exponential power of I omega t, and then plus with the exponential power of negative I omega t. Okay, and then plus with the I times A over 2 cos pi naught. Okay, times with the exponential power of I omega t minus with exponential power of negative I omega t. Okay, please simplify. Okay, hold on, I need to think back. I need to. Okay, it's the same, right? I times A over 2 cos pi naught. Okay, which plus here and then minus here. Yeah, okay, so far so good. Okay, right now let's look back. Okay, it is say that this one right here, A cos pi naught times with the negative I over 2, and then okay, I'll just copy that so you can see. Okay, this one is okay. Now you change your position. So I times A over 2 cos pi naught. Okay. Wait, hold on. No. I times A, and then these two gets out from it. So 1 over 2 times exponential power of I omega t minus exponential power of negative I omega t. Okay. Okay, and then plus with the A sine pi naught times with the 1 over 2 exponential power of I omega t times plus exponential power of negative power negative I omega t. Okay. Okay, now here, this one right here, okay, is equal to cos omega t. And this one right here is sorry. This one right here, negative I over 2. Hold on. This one, wait, what the? Wait, what? Hold on. I made a mistake. Hold on, no. Yeah. I make a mistake. Okay, sorry about that. Okay. Okay. I want to change here. This one is not available. It's like I over 2. I over 2. Okay. I over 2. Hold on. Let me see. Yeah, it should be negative here. Because A cos pi naught times with the negative 1 over 2 is like negative. It's like a negative I over 2. Negative I A over 2 here. Okay, let's look here. Negative I A over 2 cos pi naught times with the exponential power of negative exponential power of I omega t here. Okay, this is the same one. This is the same one. Okay. Hold on. Yeah, I make a mistake here. Hold on. This one is so tough. Oh, okay. Okay, sorry about that. Let's remove this one. Sorry. Let's put it here. Okay. This is minus. Okay. So A cos pi naught. Okay, negative I over 2A cos pi naught here. Okay, let's look back here. Negative. Okay. How do I say this? This should be negative. This should be plus. Okay. So when I do negative, so negative I over 2, negative I over 2, negative, this should be positive, right? So let's say positive I of IA over 2 cos pi naught times with the exponential power of I omega t, and then minus with yeah, this one, yeah. Okay, I want you to do some analysis here. If you want, if there's an equation, just let me know. I'll do it back. I just want to be quick because my experting so hell like hell now. Okay, so A cos pi naught times with the negative I over 2 multiply with negative exponential. It is right here, yeah, right here. Okay, this one right here, negative I over 2 multiply with exponential power of I omega t minus exponential power of negative I omega t. This one here is equal to sine omega t. Okay, so this one is sine omega t. Sine omega t, and then plus A sine I naught times with 1 over 2. This one is equal to cos omega t. So what we found here is that this is like a form of sine A plus B, right? Just don't look here. Let's put aside here. Look at that. It's like sine A plus B, which is equal to sine A cos B plus cos A sine B. Sine A cos B cos A sine B. Okay, so which means that for conclusion, this is actually represent as sine omega t plus pi naught, where A is the omega t, B is the pi naught. Okay, now let's go back here. Okay. So this is equal to exponential power of negative gamma over 2m, and then t times with the, since this is actually equal to this one, so this is equal to A, which is here, it should be A here, because there's A here. Okay, so it should be A, this should be A here. Okay, so A sine omega t plus I naught. Okay, but here, okay, this right here, when this equation right here comes from the simple harmonic motion, right? So that means it has a natural amplitude. So this right here will become A naught. And finally, xt is equal to A naught exponential power of negative gamma over 2m times t and sine omega t plus pi naught. There you go. And that is where, this is what this is the equation for displacement of damping oscillation when it is underdamped. Okay, so that is all. I think if there's a lot of confusion, I'm so sorry, because this is actually the toughest one, I think, to be explained. So that is all, and hope we get to see you again, and goodbye.